Next problem is called pub x of n. Basically, we are implementing a function that will calculate the x to the power of n. For example, in the example 1, we have x is equal to 2, so we are calculating 2 to the 10, which is 1024, and so on for the rest of the numbers. The third example is the negative power, which we always also can have. So in that case, we'll have 2 to the minus 2, which was basically the same as the 1 divided by 2 to the power of 2. Basically, we are converting the negative power to the positive one, and in this case, it will be 1 to the 1 divided by 4. In that case, when we turn into the decimal, we will have 0.25. Now, the constraints are that x is from minus 100 to 100. The n can be any number from minus to, basically any number between the minimum and the maximum integer, and so forth an integer, and either x is not 0 or n is equal, n is larger than 0, so we cannot have 0 to 0, which is basically undefined. And then the x of n will be, x to the power of n will be in the range from minus 10 to the 4 to the 10 to the 4. Now, the first thing that we have already gone through is that if we have a negative power, we can just convert it to the positive power by dividing any number in the negative power where n is smaller than 0 is basically the same as that same power, but as 1 divided by that power. So in this case, it will be minus n. And because n is negative, this whole will be positive. So basically, we can just calculate the negative power by just calculating the positive and dividing doing this division, 1 divided by the result as we receive. So that's the first thing. The second thing is that if we have, for example, x to the power of 4, how can we, and we have already calculated x to the power of 2, how can we use the x to the power of 2 to calculate x to the power of 4? Basically, that is x to the power of 2 times x to the power of 2. Because if we have the same base, we can add the exponents. So that means that there is a recursive relation between for this function. So if we have the half of the power already calculated, we can use that half to calculate the whole power. In this basically that means that we are calculating the half power and then calculating the whole power by just multiplying half power times half power. And this is basically the example, x to the to 2, x and x to the power of 2. So x squared in a sense. And these are working for the powers that are even, but for the odd powers, for example, x to the power of 5 would be x squared times x. So we can use the half power times the base that we have for the odd numbers. So we will basically for the recursion, we'll have two cases, the odd and even power. And the base case is when the power is equal to 0. So we'll keep on dividing the power. And then the base case for the recursion is when the power is equal to 0. In that case, any number to the power of 0 is equal to 1. So we just return 1. Now, because we will have space for the recursion calls, we have to know how many times we will call the recursion, and basically that's the number of times that we can divide the power. So that's logarithmic. Basically, the time and space complexity will be logarithmic because that's the number of times that we can halve the power. So if we have n equal to 0, then it's not we don't have to calculate anything. Basically, any number, any base to the power of 0 is equal to 1. So we just return the double version of 1.0. And if we have a power that's negative, we just do 1 divided by the power of x in the positive positive power. So we just turn the power to positive and do this calculation 1 divided by the power. This power function will be basically our helper function that we will call recursively. So in the standard case where we have n larger than 0 and basically positive, we just call our prof function. Now, the power function will just take x and n and will return a double. So we will have a base case when n is equal to 0. In that case, we just return 1. But before we calculate the x to the power of n, we have to calculate x to the power of n half. So we just divide n by 2, and basically this is the recursive part of the function. Then once we receive that result, if the n is divisible by 2, basically that means that n is an even power. Then the only thing that we have to do is multiply the two halves, basically x squared and x squared, to get, for example, x to the power of 4. But if we have x to the power of 5, it's not enough to just do x squared times x squared. We also have to multiply one more time. Basically, that's the remainder after the power has been divided by 2.